In the world of surface mount technology, precision is everything. And it all starts with stencil printing. Even small issues during your printing process can still lead to big problems at the other end of the line, no matter how good the rest of the process is. If you want to know how to maximize your yields, stick around because today we're going to be talking about stencil printing and what you need to do to get the most out of your process. Before components are placed in an SMT process, solder paste must be accurately applied to the board in the areas where the solder joints are going to form. We call this process stencil printing, and it resembles typical screen printing processes you might have seen for making things like t-shirts. The solder paste is applied to the surface of a screen, or stencil, and then a blade drags the solder across the holes, or apertures. When the stencil is lifted off the board, the paste remains stuck to the pads where the components will be placed. But with advanced technologies like fine-pitch devices, achieving precision has never been more challenging. A clean stencil ensures high-yield, defect-free prints. But what happens when the stencils aren't properly maintained? Well, you get things like poor gasketing, bad transfer efficiencies, and solder defects, all leading to scrap, costly reworks, and failures. There are plenty of published papers showing how a clean stencil can improve printing defects. And I think we can agree on that. But how should we clean? IPA may seem like an easy solution, but it falls short in dissolving modern soldering pastes. Engineered solvents, on the other hand, are specifically designed to clean the fluxes used today to enhance transfer efficiency and reduce those defects. For example, here's an image of a study showing the effect of a dry wipe, a wet wipe with IPA, and a wet wipe with an engineered solvent. In this study, a UV tracer was added to the paste to visualize where it ends up after cleaning. In the image, you can see that even with a nano coating, the only way to remove the flux residues completely is with an engineered solvent. This is not surprising given that most fluxes of today are not that soluble in IPA alone. But what about the costs? While engineered solvents do have a higher price per liter, they require less usage per wipe. Fewer misprints, reduced paper consumption, and increased efficiency means significant savings, up to $20,000 annually for a line that has only about 5 stencil printers. Switching to engineered solvents isn't just about print quality, it's about smarter economics and a more efficient process. High precision, high yields, and significant savings. Thanks so much for watching. If you enjoyed this video, don't forget to give it a thumbs up and let me know your thoughts or questions in the comments below. You can also email questions or comments to AskDrAdam@Kyzen.com. If you're new here, make sure to hit that subscribe button and turn on the notification bell so you don't miss any new episodes. And as always, stay clean.